Hello and welcome. So given the equation below, determine the x-intercepts, vertex, axis of symmetry, y-intercepts, and direction of opening. Alright, so first off, I'm not going to spend a ton of time on each topic, but I did want to go over them briefly. So first off, x-intercepts, right? What are the x-intercepts in this first box? X-intercepts are the solutions to x, meaning that you have something, comma, 0, because it's crossing the x-axis. Alright, so from there you say, okay, y value is 0, y is f of x, that means we have 0 equals x squared plus 6x plus 5, and you would solve from there. Whether you solve by factoring or quadratic formula or any other solving method, right, go for it. I personally like factoring, so that's what I'll do. 6 goes up top, 5 below, you add to 6, multiply to 5, only two numbers multiply to 5, that's 1 and 5. And because and only because you have a positive 1 as a leading coefficient, you can go straight to those parentheses. Alright, and then from there, because it's set to 0, set each parenthesis to 0. And then we subtract the 1, undo addition with subtraction, we get negative 1. Same thing, subtract the 5. And we'll end up with negative 5. So that means we have two x-intercepts. The first one will be at negative 1, comma 0. The next one is negative 5, comma 0. Now if you ever get a error message that says invalid notation, make sure you have a comma between those two parentheses, and that should get rid of any kind of weird notation kind of error that's showing up in red letters on the side. Now if it says syntax error or maybe a few others and adding that comma in isn't fixing it, you might have something wrong. Make sure you're using commas instead of periods or something else, right? Just keep an eye on what you're typing in. So that is your x-intercepts. Now coordinate point of the vertex. There's two ways you can find the vertex here. The first way is you could say, okay, I know that the quadratic is supposed to be a U-shaped graph, meaning that the vertex is going to be that turning point of the graph, and I know that the vertex, if that's at 1, that's at 3, the vertex would have to be at 2, right? Or if the x-intercepts were at 1 and 3, the vertex is at 2, because it has to be the middle. Well, we know our x-intercepts. We know one's at negative 1, the other is at negative 5. If you combine those and find the halfway point, we get negative 6 divided by 2, which is negative 3. So negative 3 comma something is that vertex. Now, you can also find the vertex by saying, hey, this is in standard form. There's no parentheses here. So negative b over 2a also works to find your vertex. You can take that 6, what's negative of 6, negative 6, over 2 times a is 1, so 2 times 1, 2, negative 6 divided by 2, negative 3. Okay, you can find it either way, they both work. Where you're finding your x-intercepts anyways, it might be a little faster just to use these, because that will always work. And you're like, great, now I know the x-coordinate, how do you find the y? Well, we know x is negative 3. Plug it in. If you know that x is negative 3, plug in negative 3. So then we get negative 3 squared. Yes, you do need those parentheses there. 6 times negative 3 plus 5. Alright, so then negative 3 squared, 9. 6 times negative 3, negative 18 plus 5. And then we end up at 14 minus 18, which is negative 4. Done. Okay, nothing too crazy there. And there is your vertex, and either way, whether you use the x-intercepts or the negative b over 2a, you would still have to plug in x to get out the y. Okay? Alright, so that's that. Axis of symmetry is super easy to find. Axis of symmetry is essentially, if you were to fold your graph, that fold line is the axis of symmetry if you want to fold it in half equally on both sides. Now, you'll notice that this is a vertical line. It'll always be a vertical line, and it will always run through the vertex. Alright? Now, vertical lines cross the x-axis, so they start with x equals. which means you're grabbing, because it's running through the x values, you want the x value of your vertex. And there's your axis of symmetry. Whatever this value is always going to be the same value there. Always. Okay, there's no exception to that, because for a quadratic, the axis of symmetry will always run through the vertex. Alrighty, now coordinate point of the y-intercept. This one's not too bad to find. A y-intercept we know is written as 0, comma something, where the 0 is in place of x. Plug in 0 for x, that's it, that's all you have to do. So then we have 0 squared plus 6 times 0 plus 5. Now if you put those parentheses there or not, this one it won't matter, but if you're not sure when it does or doesn't, always just put them to be safe. Okay, so 0 squared, 0, plus 6 times 0, 0, plus 5, 5. Wow! Okay, when in standard form, you might notice that your constant, the value without a variable, will always be your y-intercept in standard form. Always. Okay, and almost there. Direction of opening, we're going to be going up. How do we know? Our leading coefficient, our 1 in front of the x squared, that's a positive number. Positive is up. If it was a negative number, it'd be going down. And that's all the information. Last but not least, it asks us to plot x-intercepts, if any, the vertex, axis of symmetry, and the y-intercept. So we have x-intercepts, we have 2 points, we have -1 and -5. So we have -1, comma 0, and -5, comma 0. Alright, coordinate point of the vertex, -3, comma -4. So -3, -4, right there. Now be careful, these are scaling in terms of 2, right? So it's not 4 down on the lines, and it's not 4 tick marks. Keep an eye on what your scale is. Okay, so there's your vertex. And then we have x equals -3 as the axis of symmetry. It's going to be purple. I don't have purple. I do now. Alright, so when we're looking at that, we're going to be using the line tool. So before we've been using the dot tool, now use the line. Now you'll notice for the line tool you need 2 red dots. Those are not dots on the graph. They are not dots anywhere. They're not these dots for sure. They're just 2 dots along where the line should be. So if we know that there's supposed to be a line at x equals 3, so here's your x-axis, so that means x equals -3. You should have your line here, right? It should be running all the way down. Okay, now this is actually going to be a solid line, not a dashed line. That's okay, not a big deal. Alright, now when you're placing these, what it means for those 2 red placer dots is those 2 red dots are not your vertex or the x-intercepts. I mean, it can be the vertex if you want it to, but it's just 2 dots anywhere along the line. So if you want a dot there and there, sure, that'll work, that'll place the line. If you want the dots up here, sure, that'll place the line. What if you want 1 dot at the far end of each side? That's okay. As long as there are 2 dots on the line, that's totally good. Now, does it have to be actual circle dots placed on the graph? No, it doesn't. The red dots that you place for this line are not going to make a single difference. That's just helping you place the line. It doesn't actually mean there are actual dots there. Keep that in mind. That's how you use the tool. Alright, and last but not least, the y-intercept, which is at 0, 5. Again, keep an eye on the scale. It's between 6 and 4. Here's 5. There you go. There it is. That's everything that it wants you to plot. Okay, we'll worry about crafting the quadratic at a later time, which is essentially just connecting those dots together, right? But for now, you're just plotting all of the information. And that's it. Thanks for watching.